Lesson 12.1, Inverse Variation, and Lesson 12.2, Rational Expressions. Let's back up. What type of behaviors have we modeled so far? Well, we've done linear. If you look on a graph, linear, shockingly enough, forms a line. We have done exponential. And exponential either takes off or slows down and just goes right up through the roof. Got a nice curve, but just one of them. And we just finished a couple units ago, quadratic. And I'll draw this one upside down because quadratic is the motion of things. Throw a ball up in the air and it comes back down. So now we're going to do one more for the year, and it's an inverse variation, also known as indirectly varying. So that would be something like in physics, you have acceleration is force over mass. You would say acceleration and mass are inversely related. So that's what an inverse relation is, and we'll show you some more about that. The typical way it is shown is one of two ways. Y equals k over x, because most of us are used to seeing y equals. The other one would be that xy equals k. These are the same equations, just written different ways. So it helps to see it as xy equals k because it helps with the next part when you look at something and say, is this or is this not inversely related? So, which of the following is an inverse relationship? Which is direct. Direct would mean that the y and the x are on the same side in terms of above or below the line. So this is direct. This we just talked about. This is indirect. And I won't give you any problems that involve these, but it's good to know what you're talking about. Which is neither. This is neither. There's no C value for an inverse or direct relationship. They don't move up or down on the y-axis. They are just directly or indirectly related. And it's just a natural equation thing. Equations you'll see in physics or chemistry or biology, things like that. So, as always, we need to graph. And we'll put 2 up there. And you can throw this in your calculator if you'd like, but I'll show you real quick and then I'll show you a way to graph it. It's almost always going to look something like this. It is always going to look either something like this or something like this. And this is y equals negative 1 over x, and this is y equals 1 over x. And we know that because if this is what y equals 1 over x is, negative 1 over x just flips it down and up. So this one came from the bottom and this one went down. And again, you can look at that in the calculator if you want. It's called the hyperbola. 2 curves that reflect each other on opposite sides of the graph. So how would you graph? Well, first off, we have x equals 4 while y equals 9. Multiply them. So xy equals 4 times 9, xy equals 36. Y equals 36 over x is your equation. Now, every time you multiply these, you're going to get 36. So pick some nice, easy numbers to work with. 3 of them should be enough. So 12, 6, 2. 12 times what is 36? 3. 6 times 6. 2 times 18. And now the nice thing is the negatives just go the other way. And I'm probably not doing this the most precise way, but it doesn't matter. We're just going to throw up some points and see what we get. Now we'll see the relationship we just talked about. So if I put in 12, I get out 3. If I put in 6, I get out 6. If I put in 2, get out 18, somewhere up there. Connect the dots, and there's your curve we just showed you. Bottom, the same thing happens. 2 down, we're down here. 6 down, about there. 12 out, about there. There we go. That's y equals 36 over x, just like we said it would be. You can see the properties of the inverse relationship there. As we move down along the x-line, we get closer and closer. As we move further up the y-axis, we get closer and closer. These are called asymptotes, which we're not going to get into. That means that the equation keeps getting closer and closer to them without ever actually touching them. Now, just a little bit more on the equations. I will make you do this. If they vary inversely, and when y equals 4, x equals negative 3, so let's, before we even do anything else, xy equals negative 3 times 4, xy equals negative 12, y equals negative 12 over x. There's my equation. That's the inverse equation. Now, if y equals 2, 2 equals negative 12 over x, cross multiply, 2x equals negative 12, x equals negative 6. If x equals negative 6, we really don't even need to do anything else. We know y equals 2, but hey, let's do it right. We would get negative 6, y equals negative 12 over negative 6, y equals 2. So they're really not that challenging to manipulate, and they don't even get that much harder than that. Now, this moves into the next lesson, actually, which we'll lump together. What's a rational expression? What's the first 5 letters? Ratio. So that's a y equals 2x plus 1 over 3x minus 4, whatever. So it's a fraction with variables in both the numerator and denominator. We just showed you what the graph of one of these will look like, and that one would actually plot out somewhat similar, although the asymptotes would be moved around. Now the problem is the bottom. This is what you have to worry about. Can't divide by 0. So if I put the variable 4/3 in here, we'd end up with 0 on the bottom. That's actually where the asymptotes are. Can never actually have that, so we never actually run up to them. And we have to watch out and list all the time our excluded values, which means the values that we can't have. There's a lot of reasons to do this, the biggest one being that at the end of the day, when we solve equations involving rational expressions, we have to double check and make sure we haven't used one of the excluded values. So for example, here we would say x cannot equal negative 7 over 2. Here we'd have to factor it, a minus 5, a plus 2, and we would say a cannot equal 5 and negative 2. And that's it. That's in terms of finding excluded values. Now what would you have to do with this? I think you obviously can guess. We got to reduce it. So we pull out negative 1, pull out a 7, get rid of the m, get rid of the squared, get rid of all the n4th, get rid of the squared, and get rid of the p, and rewrite. We would get negative m over 7p. Don't forget, x, no x here, m cannot equal 0, n cannot equal 0, p cannot equal 0. You might look at this and say, but there's not even an n in here anymore, and m is no longer on the bottom of the fraction. Well, that's all right. This is what we started with here, and we have to consider, do we have m, n, or p equaling 0 before we even start the problem? You got to watch out for that. Again, excluded values. So these, let's reduce them. First things first, always factor. Pull out negative 4x, see where that takes us. Great, and cancel this. And that is our final answer. As long as we say x cannot equal negative 4 or negative 2. Not too hard. Takes a little practice, and you have to constantly remember things, but that is math in a nutshell. Factor the top, factor the bottom. Some of you are probably saying right now, I'm not really that good at factoring. Then you're in very big trouble, and you better go back and refresh yourself, because that is almost exclusively what you'll be doing in this unit. X cannot equal negative 5 or negative 2. That's reducing rational expressions so they're easier to handle, but also saying, well, even though I've changed the equation, I have to go back to the original equation and make sure I don't put any values in there that are going to blow up my calculator. I believe I've used other ways to describe how your calculator feels about that. That's it. Good luck.